Greetings to everyone. Today we are going to see about periodic classification of elements. We live in the world of substances with great diversity. Substances are formed by the combination of various elements. All the elements are unique in their nature and property. To categorize these elements according to their properties, scientists started to look for a way. In 1800, there were only 31 known elements. By 1865, their number became 63. Now, 108 elements have been discovered. Early concepts of classification of elements. First one is Daubonier's triads. In 1817, John Wolfgang Daubonier, a German chemist, suggested a method of grouping elements based on their relative atomic masses. He arranged the elements into groups containing 3 elements each. He called these groups as triads. Tri means 3. Daubonier showed that when the 3 elements in a triad are arranged in ascending order of their atomic masses, the atomic mass of the middle elements is nearly the same as average of atomic masses of the other 2 elements. This statement is called as Daubonier's law of triads. Limitations. Daubonier could identify only 3 triads from the elements known at that time, and all elements could not be classified in the form of triads. Next one is Newland's law of octave. In 1866, John Newland arranged 56 known elements in the increasing order of their atomic mass. He observed that every 8th element had properties similar to those of the first element, like the 8th note in an octave of music is similar to the first. This arrangement was known as law of octaves. Limitations. There are instances of 2 elements being fitted into the same slot. Example, cobalt and nickel. This is the table of Newland's octave. Next one is Mendel's periodic table. In 1869, Russian chemist Dmitry Mendeleev observed that the elements of similar properties repeat at regular intervals when the elements are arranged in the order of their atomic masses. Based on this, he proposed the law of periodicity, which states that the physical and chemical properties of the elements are the periodic functions of their atomic masses. He arranged 56 elements known at that time. According to his law of periodicity, this was the best known and as a short form of periodic table. Features of Mendel's periodic table. It has 8 vertical columns called groups and 7 horizontal rows called periods. Each group has 2 subgroups A and B. All the elements appearing in a group were found to have similar properties. For the first time, elements were comprehensively classified in such a way that elements of similar properties were placed in the same group. It was noticed that certain elements could not be placed in the proper group in this manner. The reason for this was strongly determined atomic masses. Limitations. Elements with a large difference in properties were included in the same group. Example, hard metals like copper and silver were included along the soft metals like sodium and potassium. This is a Mendel's periodic table. Modern periodic table. In 1913, the English physicist Henry Moseley, through his X-ray diffraction experiments, proved that the properties of elements depend on the atomic number and are not on the atomic mass. Consequently, the modern periodic table was prepared by arranging elements in the increasing order of their atomic number. This modern periodic table is the extension of original Mendel's periodic table and known as a long form of periodic table. Modern periodic law. Atomic number of an element Z indicates the number of protons or the number of electrons. The physical and chemical properties of the elements depend not only on the number of protons but also on the number of electrons and their arrangements, that is, electronic configuration in atoms. Hence, the modern periodic law can be stated as follows. The chemical and physical properties of the elements are the periodic functions of their atomic numbers. Based on the modern periodic law, the modern periodic table is derived. Features of modern periodic table. All the elements are arranged in the increasing order of their atomic number. Horizontal rows are called periods and there are 7 periods in the periodic table. The elements are placed in the periods based on the number of shells in their orders. Vertical columns in the periodic table, starting from top to bottom, are called groups. There are 18 groups in the periodic table. Based on the physical and chemical properties of element, they are grouped into various families. These are the groups in the modern periodic table. Alkali metals, alkaline earth metals, transition metals, boron family, carbon family, nitrogen family, oxygen family or chalcogen family, and halogens, noble gases. There are 4 blocks in the periodic table. They are S block, P block, D block and F block. S block elements, it includes group 1 and group 2 elements that are alkali and alkaline earth metals. They are also called as representative elements. Elements of the group 2 are also metals. They combine with oxygen to form oxides, formerly called earths, and these oxides produce alkaline solution. When they are dissolved in water, hence these elements are called alkaline earth metals. Next one is P block. These elements are in group 13 to 18 in the periodic table. They include boron, carbon, nitrogen, oxygen, fluorine families in addition to the noble gases. They are also called as representative elements. The P block is a home to the biggest variety of elements and it is the only block that contains all 3 types of elements: metals, non-metals and metalloids. Third one is D block elements. It includes group 3 and group 12 elements. They are found in the center of the periodic table. Their properties are intermediate to the S block and P block elements, and so they are called as transition elements. Next one is F block elements. It includes 14 elements after lanthanum called lanthanoids and 14 elements after actinium are called actinoids. They are placed at the bottom of the periodic table. They are also called as the inner transition elements. Advantages of the modern periodic table. The table is based on the more fundamental property, that is atomic number. It correlates the position of the element with its electronic configuration more clearly. The completion of each period is more logical in a period as the atomic number increases. The energy cells are gradually filled up until the inert gas configuration is reached. This is our modern periodic table of the elements. Thank you.